change in time. So that is the rate of change in momentum. This rate of change in momentum, that is momentum change in the given interval of time, that depends completely. The momentum is changed due to what? It is changed due to the application of external unbalanced force. This rate of change in momentum is directly proportional to the force impulsed on it. Impulsed, it produced the effect. Impulse means to produce the effect. Here, this rate of change in momentum is directly proportional to the force impulsed on it. So, this we call the directly proportional. Directly proportional means when we increase the external unbalanced force, the rate of change in momentum also increases. In class 8, you could have studied about the direct variation and inverse variation. Direct variation means if two quantities, if one quantity increases, another also increase. We say they are directly varying. And in physics, in mathematics also we say they are directly proportional to each other. In two quantities, if one increases, another decreases, then they are inversely proportional. Here, the force impulsed on it, the force, external unbalanced force impulsed on it, is directly proportional to the rate of change in momentum, and this is the statement of Newton's second law. Newton's second law of motion. For the Newton's second law of motion, the complete statement is the rate of change in momentum produced in an object is directly proportional to the force impulsed on its direction of motion. In its direction of motion. That is the statement of Newton's second law of motion. This is the basic formula for the Newton's second law of motion. From this formula, we are going to obtain the standard formula, the formula which we are going to use. Okay, so P1, delta P means P2 minus P1. P2 final momentum, that is mv. P1 initial momentum, that is mu. Right? Okay. Now, here we have written that F directly proportional to delta P upon delta T, that is rate of change in momentum. Here it is only proportional. One increases, other also increases. They are not equal. Here we can put the equal also, equal symbol. By removing this proportional symbol, we put the equal. While doing that, you have to put some constant k, that is delta P upon delta T. In this, the constant is not significant, it is not important. That's why the constant can be neglected. By neglecting the constant, F equal to delta P upon delta T. Whatever the force is applied, that force is equal to the rate of change in momentum. Right? Okay. Now let us move on to the next part to obtain the formula for the calculation. So F equal to delta P, that is change in momentum, P2 minus P1, and delta T, that is change in time, T2 minus T1. Right? If we put in the beginning, if the time is 0, always whenever we are going to observe the motion of any object, in the beginning we consider the time is 0. So here also we are assuming the initial time is taken as 0 and the interval, finally the time taken is t. So we write F equal to P2, that is final momentum, it is written as mv, and minus, this is mu, upon T2 minus, that is T minus 0. Now we get the relation. It is F equal to this m constant, m is common, and we write V minus U upon T. So that is V minus U upon T. change in velocity upon time taken, or we can say it is rate of change in velocity. The rate of change in velocity, it is the acceleration. Therefore, finally we get the relation F equal to m into this terms, it gives the acceleration. So finally we got the relation, the force is equal to m into a. Force is equal to mass into acceleration. It gives what? Whenever we apply the force on any object, the force is applied, external unbalanced force is applied on any object, it produces the acceleration, and that force can be calculated. The force can be calculated by using this relation F is equal to m into a. So in this Newton's second law of motion, we are able to measure the magnitude of force required to move the object, to change the state of object, that is by F equal to m into a, or it can also be used, this relation can also be used, F equal to m v minus u upon t, this can also be used. Both are same, both the relations are same. So this is the final. So the force can also be numerically the force is equal to, it is equal to product of mass and acceleration. It gives what? Whenever we apply force on any object, the acceleration is produced. Acceleration produced means its velocity changes. Its velocity changes means it is not in uniform motion. Its motion will be accelerated motion. Right? So this is the relation for the Newton's second law of motion. Relation we obtain, final relation. But the basic relation is F is equal to delta P upon delta T. From this relation we got F equal to m into A. Right. Now from this relation we measure the force. So the Newton's second law of motion gives the measurement of force. It gives measurement of force. The first law of motion gives definition of force. Second law of motion gives measurement of force. Because by using this law, we can measure the force. How much force is required to change the object. Right? Okay. Now, from this relation, that is F is equal to m into A, we can obtain its unit also. Because all the physical quantities are having SI units. Already we discussed the SI unit of displacement, velocity, acceleration, all the quantities have been given units, SI unit. Velocity SI unit, meter per second. Acceleration SI unit, meter per second square. Mass SI unit, kilogram. Time SI unit, time, that is seconds. Here the force is also having the SI unit. Force. Since the measurement of force, that is the force can be measured by using this relation, that is from Newton's second law of motion. In the name of scientists, the unit of force is given. So unit of force. Unit of force. See, all the quantities are having SI unit and also having the smaller unit, that is CGS unit, that is smaller unit. Here we are going to talk about the SI unit of force. SI unit of force is Newton. So what is the SI unit of force? Newton. Symbolically, we use the capital letter N. If we write the complete spelling,